Now with strong data governance in place, let's turn our attention to how we can actually put it to use. Last year, we announced Databricks SQL capability on Databricks to allow data analysts to directly query the most recent and most complete data in the lakehouse through tools like Tableau and Power BI, rather than waiting for outdated excerpts be made available in downstream data warehouses. Since we announced Databricks SQL, we've been focused on several aspects of this experience. First, we've been hard at work to make it super fast to query the data and also reduce the latency of it. Second, we've continued to scale up the concurrency to enable very large data analyst organizations to have a delightful experience. Third, Databricks SQL now provides even better visibility into workloads, usage, and troubleshooting. I'm excited to have you see all the progress that we've made, and I'd like to welcome Reynold Xin, Chief Architect at Databricks, to walk you through it.
Thank you, Ali. Good morning, everybody. At the last Data and AI Summit, we announced a new product targeting SQL and BI use cases called Databricks SQL. The approach we have taken is very different from traditional data warehouses. So rather than taking a closed approach to manage data, Databricks SQL relies on the lakehouse architecture to store and govern data in an open way. This way, it shares the same underlying storage and governance with the rest of the use cases, such as data engineering, data science, and machine learning. In this talk, I want to give you some update on the progress we have made since then. Our vision for Databricks SQL is very simple. We want to provide the most performant, the simplest, and the most powerful SQL platform. And we'll do this in an open way, and open doesn't have to come at a cost. SQL is a very important part of the lakehouse, and there are a lot of capabilities that go into offering a great BI and SQL experience. We'll make some major announcements here. For example, in the earlier talk today, you have heard that Matei announced a Unity catalog to provide cataloging and governance for your data. At the last Data and AI Summit, we announced a combination of SQL endpoints and the Photon vectorized engine to bring state-of-the-art performance to the lakehouse and a better interface based on our Redash acquisition for SQL users. However, as all of you know, we don't get to realize a long-term vision by just a sequence of announcements. We get there by working closely with you, our customers, to improve the system over and over again. In this talk, I want to share with you some of the exciting improvements we made. Given Michael has already talked to you about the storage layer and Matei on the catalog and governance, I'll start at the next layer above to talk about the work we have done to improve real-world performance, followed by some of the UI work. And these improvements are part of the Photon engine. For those of you that attended my talk at the last Data and AI Summit, you might remember a chart I showed that compares Databricks SQL performance with the other cloud data warehouses using TPC-DS 30 terabyte scale benchmark. Since TPC-DS is an industry standard benchmark defined by data warehousing vendors, we're really proud that we could beat them in their own game. However, some of you also pointed out that since Databricks started as a massively parallel data processing engine, it's not surprising that Databricks SQL to do really well in benchmark that process terabytes. As a matter of fact, 30 terabytes of data. Our Achilles heel is in the other scenarios. So we heard you. And for the past 6 months, as we were previewing Databricks SQL with our customers, we worked with a lot of them on their real-world workloads and focus on optimizing those. And in the performance section of the talk, I want to cover a few real-world scenarios. This includes small concurrent queries, mix of small and large queries, a lot of small files with poorly laid out data, and the last mile delivery of data to the clients. The top question in all of your minds have been, yes, Databricks is really great for crunching a lot of data, but how well would us do with a lot of users and small data sets? So to measure that, we used the TPC-DS benchmark again, but this time using only 10 gigabyte scale factor. So going down from 30 terabyte to just 10 gigabyte. It's a much smaller one. And 32 concurrent streams to simulate a lot of users. We first measured actually one of the best cloud data warehouses, and we saw that it could process around 11,000 queries per hour in this scenario. Back in July last year, when we measured Databricks SQL, it was able to handle only 5,000 queries per hour using a similarly priced system as the cloud data warehouse. So we then put together a SWAT team to look at the problem, analyzing where the bottlenecks were and removing them one by one. There's really no single brilliant algorithm here, just a lot of hard work, shaving things off one by one. In November last year, we made quite a bit of progress and improved the system by 40%. Now it could process actually 7,000 queries per hour, and we continued. And I'm super excited to actually show you that after over 100 different micro optimizations, we measured again in May, and we found that we've tripled the number of queries that can be processed per hour in just less than a year. And Databricks SQL now outperforms the cloud data warehouse, not only for large queries, but for small queries with a lot of users. Of course, we're not done here. We have identified a lot of other changes to improve concurrency and short query processing even more, and we'll share with you in the future conferences. But real-world workloads are not just small queries or just large queries. They instead include a mix of small and large queries. And we have seen a lot of those in the past few months as of Databricks SQL preview, and we'll work very closely to add specific optimizations for them. Previously, Databricks SQL had a single queue for all queries. And that is when the system's saturated and as new queries keep arriving, they get queued up and will be executed when some capacity of the system freed up. And this would actually cause a problem with large queries blocking small queries. And consider the example I'm showing you on the screen here. At 5 o'clock, we have a very large query that's using all of the capacity of the system. Then 5 minutes later, 2 small queries came in. Perhaps the CPU is trying to open a dashboard with those 2 queries. And those 2 queries typically just run for a couple seconds because they're very, very quick and use very little resource. However, because of a large query have consumed all of the resources in the system, those queries would have to wait until 20 minutes later. And this means the CEO actually waited more than 15 minutes for the 2 queries that's supposed to take just 10 seconds to complete. 15 minutes rather than 10. So we have received a lot of feedback from customers, and we designed actually a completely new approach to solving this problem. And the insight between our new approach is that most end users really care about the latency or how fast you can run the short queries, and not much about the latency of long-running queries or large queries. In this new approach, instead of having a single queue, we will now have 2 different queues, and a standard queue and an express queue. Queries that come into the system are analyzed first to determine if they are large or small. If they are large, they go into the standard queue, and if they're small, they run into the express queue. So in the same example, at 5:05, when 2 small queries come in, the system will process them immediately without the large query blocking them. This way, the 2 short queries are processed within 10 seconds, and the large queries runtime had barely had any impact. And this really simple dual queue approach makes the system feel a lot snappier to all users, regardless whether they're running smaller queries or larger queries. The third scenario I mentioned earlier is too many small files, and this can happen for a lot of reasons. For example, a streaming job without compaction could accidentally create a lot of small files without the users even noticing. And to read 10,000 1 megabyte files, the most of the time in the system will actually be spent just opening and closing those connections rather than reading the content of the files, which is what we want the system to do. And this would significantly slow down the system as opposed to reading, for example, just 100 megabyte files. And this is often called out as the main Achilles heel of an open system because the system doesn't have complete control over the underlying files. To alleviate this problem, we designed a new scan operation called async and parallel I/O that can automatically read the next blocks of data while the current block is being processed. And this actually increases the performance of the small files dramatically by 12 times for 1 megabyte files as we've measured here. In addition, the same optimization doesn't just help small files. It also helps when the files are large, but they're just residing code in the object stores and not cached locally in the system. So really bringing much better I/O performance across the board. The last performance feature I want to talk to you about is about the last mile or the boundary, how the system delivers results to clients. This is very important for anybody trying to get a large amount of data out of the system, like a BI extract scenario. And previously, just like pretty much any other data warehouse, a client would fetch data in a single thread going through a single node, typically like a coordinator node. Not an issue at all if the client's just trying to fetch a couple megabytes, but can be very, very slow if the client's trying to fetch hundreds of megabytes or even gigabytes of data sometimes. So we've reworked this with a really cool architectural change that for large results, the underlying cluster now write in parallel across all of the compute resources to cloud storage like GCS, Azure Blob Store, or S3. And then the server sends a list of files using precise URLs back to the client. The client can then download all the data in parallel from the object stores. So this is to say, all of the metadata are sent in serial order because they are small, but all the data that are large can be parallelized both in the writing phase and the reading phase of the client. And we call this cloud fetch. In the real-world customer scenario we have tested, we observe actually up to 10 times performance improvements for end-to-end query execution time. So this includes the time for a BI client to actually fetch all of the data. And it's quite incredible. What I've shown you just now, a list of very different scenarios I worked on for real-world performance beyond just one single industry benchmark, TPCDS. The goal is to provide you the best price performance for SQL workloads while retaining all of the benefits of the open platform. The key enabler for this is the Photon engine, and we announced private preview of it last year. I'm happy to announce that Photon will enter public preview phase in the next few weeks. But all of you know that performance, while it's extremely critical, isn't everything. When we're creating Databricks SQL, we want to build not only a really performant product, but we also want to create a very simple product, simple as in easy to use. Next, I want to show you some of the progress we make in simplicity, starting with admin experience, followed by analyst experience. Admin's first impression in Databricks SQL is usually the how simple the form is for creating a SQL endpoint. This is because with SQL, the underlying system has now more opportunities to understand the workloads, as opposed to generic Spark workloads that might be a little bit difficult for the underlying system to understand. Databricks SQL takes full advantage of that. It will automatically tune the underlying resources for SQL. For example, it automatically picks the best VM types, so customers don't have to worry about what type of VMs run best for SQL queries. It automatically tunes the configs, so the cluster's auto-tuned. It automatically scales the system as load comes in for more concurrency, and it's really, really easy to get started. It's also really easy to monitor. We provide a simple and beautiful UI for admins to understand their workloads. They can quickly look at sort of the monitoring tab to understand how workload vary across time, and they can drill into specific time periods if needed. Now, of course, admins can also look at the set of queries that run against a system in the query history page. Admins or users themselves can also leverage the query detail page to understand the performance characteristics of those queries, like where are they slow. This is a much better, simpler to use, and beautiful UI for SQL queries than what the old Spark UI provides. In addition to the administrative simplicity, we've also dramatically improved the SQL developer and analyst experience. First of all, we work very closely with a large number of software vendors to make sure you can easily use your tools of choice on the Databricks SQL product. We already told you a lot in the past about Tableau and Power BI, but the ecosystem is so much larger than that. We made it easier to connect, easier to get data in, easier to authenticate using single sign-on, and of course, with all the concurrency and short query performance improvements, we make sure that the direct and live query performance is great. But we're also focused on providing a first-class SQL development experience within Databricks SQL. We've talked to hundreds of analysts that use various kinds of SQL editors like SQL Workbench every day and work with them to provide a dream set of capabilities for SQL development. We've added a long list of features that I won't be able to go through all of them, but some of them are highlighted on the screen here, and this includes the query tabs, so you can work on multiple queries at the same time, autosave, so you never have to worry about losing your drafts, integrated command history, so you can easily look at what you have run in the past, and much better autocomplete that understands subqueries and query aliases. We've also added debugging capabilities in the editor, so now you can see query progress, error highlighting, execution time breakdown without ever changing the environment. And last but not least, we stay true to Databricks' unified approach for collaboration with a lot of rich set of features for collaboration here. I personally found it very difficult to understand how well a product works just with screenshots. So I want to invite John Efiolu, our product manager for Databricks SQL, onto the stage to show you a quick demo of what I've talked to you about so far.
Thanks, Reynold. Let's get into it. Imagine that you and I are data analysts at a chocolate bar company, and we're tasked with figuring out which regions to source our cocoa beans from to get the best value and ratings for our chocolates. Let's start by taking a look at the chocolate database here, which contains all the data for this project. And the data browser really shows us the details here about the individual tables as well as their columns. And the reviews table seems to be the one we need. So let's get a quick preview to confirm that it is. This looks good, but I do want to keep this preview readily accessible for later. So I'm going to switch to the Previews tab. And the new tabs in the SQL editor honestly makes multitasking super easy without losing any context. So let's start working on that query now. And as I type, honestly, autocomplete saves me so much time here, as well as additional clicks. It's gotten smarter too, and now works with things like more complicated queries that include subqueries or aliases that are deeply nested. And now that we made the query look a bit prettier too, let's go ahead and execute. And you'll notice the progress indicator tells us the stage of the execution, so you always know what's going on as well. And if you ever need to go back to a previous query or its results, you can just use the integrated query history for this. You can go back in time to any of these queries, view their results, and if you want to, leverage them for your analysis or just go back. And coupled with the new auto save and drafts features, you will never have to worry about losing work, even if you just close your browser windows here. Now, to switch gears a bit, let's imagine that we're instead administrators managing SQL endpoints. Creating one is simple. Pick a name, pick a t-shirt size, and just make sure the right folks have access. This is all synced to your identity provider automatically behind the scenes. And you're done. It'll scale based on your user and workload loads automatically. So you have that peace of mind. And for an existing endpoint, understanding usage is simple too. You can look at workload trends and peak usage periods right from the monitoring UI. In this case, looks like May 11th through 14th has been a busy week for that endpoint. The query history gives us a way to drill down even further here. You can view activity from BI tools, the built-in SQL editor we just looked at, or any other client. You can filter this by a specific endpoint, a specific set of users, a date and time period, as well as the status of a query. And for an individual query, getting insights on where the time was spent and any other execution details is a breeze to with that new execution summary pane. And this is huge in terms of time savings for administrators trying to do auditing and troubleshooting. And that concludes our quick walkthrough. We're very excited about the progress so far, and even more so about what's to come. Back to you, Reynold.
Thanks, John. I hope this talk and demo give you a good understanding of the progress we've made. We have achieved best-in-class performance for a lot of different real-world scenarios, from small queries to large queries to a mixture of large and small queries. We made it dramatically easier to use your favorite BI tools and provide you a first-class SQL development experience directly on top of the Lakehouse platform. We're not sitting still. As you're watching this talk, our team are working nonstop on a whole new set of capabilities that will provide even more speedups, make the platform even simpler, and even more pleasant to use. At this conference, there are a number of talks about various different aspects of Databricks SQL from both Databricks and our customers, and I've shown some of you on the screen. I would encourage you to check them out. Last but not least, starting June, we'll public preview Databricks SQL as well as the Photon engine. You can go to databricks.com/try to get started. Thank you very much. Enjoy the rest of the conference. Passing back to you, Ali.